to start with this color. All right. So the first thing that we're going to put on here is degrees. So I'm going to put those inside the circle toward this inner part of the circle. Okay. So we start over here. Yeah, all these degrees will be one color. So the first thing will be 0 degrees. The next line is 30 degrees. This next one is 45 degrees. Then 60 degrees. And then the one straight up and down is 90 degrees. All right, so between an axis and the first line, there's 30 degrees. And then between these in the middle, there's 15 between them. Okay, so when I come over here, this next one is going to be 120 degrees.
Yep.
Then 135 degrees. It's kind of
160.
no, 150.
I was close.
150 degrees.
180. Oh.
And then 180 degrees. And then we keep going down into quadrant 3. We've got 210 degrees. 225 degrees. 240 degrees. Down here is 270 degrees. In quadrant 4, we've got 300 degrees. 315 degrees.
Saw your trophy.
330 degrees, and then all the way back around, we have 360 degrees. Okay, so I'm just going to tell you, that 0 is really large, I'm going to fix it.
Something wrong. This is...
So, we start out at 0 degrees, and we end at 316 degrees. There are 17 total degree markings that will be on here. Okay?
How many degree markings?
There's 17 of them.
How is yours in a circle? Yeah, mine was not circular at all. Mine was very circular.
It's okay. Usually the first time it doesn't look as good.
Whoa. It's like a snail.
All right, now, the next thing I'm going to do are radians. Okay, and I'm going to do these kind of out of order because I'm going to teach you how to count them. Okay, so these are all going to be one color, but I'm just going to teach you how to count them as we go so that it's not as chaotic. All right, so out here, okay, we start at 0. So just like degrees, radians start at 0. Most people, the thing that they miss out on points on this stuff is that they don't put the 0 both times. If you don't write it both times, I will take off points. That's how it works, okay? So radians start at 0. Then I'm going to count, first of all, just the axis points, okay? So this is 0. This is pi over 2. So straight up and down is pi over 2. Over here, this is pi. So half the circle is pi. We keep going around. So this is 1 pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2, which reduces to 2 pi. Now, the next thing that we do is we do the increments of 45 degrees, okay? The increments of 45 degrees also include the 90s, okay? So, starting at 45 degrees up here, this is pi over 4.
Oh, this is the same color. Okay, guys.
So this is 1 pi over 4. At 90 degrees, we're at 2 pi over 4, which reduces to pi over 2. 45 more degrees, we're at 3 pi over 4.
Go.
Another 45 degrees, we're at 4 pi over 4, which reduces to pi, which you already have. Another 45 degrees, we're at 5 pi over 4. Then 6 pi over 4, which reduces to 3 pi over 2. We already have that. Then 7 pi over 4. And then all the way back around at 2 pi is 8 pi over 4, which reduces and gives us the 2 pi. What?
I got the pie.
All right.
Put the pie out of the bag.
Next one I'm going to do are the increments of 60 degrees. Now, 30s and 60s go together, but I'm going to do 60s first because their denominator is all the same. Okay? And then when we do the 30 degrees, you'll see what I mean by everything reducing down. Okay? Now, 30s also go with 90s, 60s don't. So, all right. So, at 60 degrees, so the increments of 60 degrees, we're in pi over 3s. Okay, so at 60, it's pi over 3. So that's 1 pi over 3. We go 60 degrees, so that puts us up here at 120 degrees. That's 2 pi over 3. We come down here. This is 3 pi over 3, or just pi. Another 60 degrees puts me down here, which is 4 pi over 3. Another 60 degrees is 5 pi over 3. And then all the way around is 6 pi over 3 or 2 pi.
Nice.
Are we tracking so far?
Sad if I take a picture from my wife.
That's fascinating.
All right. The last ones that we have are the increments of 30 degrees. That means every 30 degrees. So 30, 60, 90, 120, 150, 180. All of those things going around are increments of 30 degrees. But their radians will reduce to what we've already written, except for the ones that we haven't filled in yet. Okay? So 30-degree increments happen in pi over 6s. Okay? Now, does anybody know why these have the denominator? Have you figured out why they have the denominators that they have yet?
To show us.
Wait,
Why
Are
does
you
it-
answering my question or are you asking a question?
I had a question, but someone else answer the question because it's not as important.
I'm thinking. Hang on, I might have an answer.
Is it?
It's the number divided by 180. Nope.
I don't know. Never mind.
I'm guessing that dividing pi by that number gives you that degree.
Well, not the degrees so much, but in half of the unit circle, pi over 2 that's broken it into 2 pieces. Pi over 3s have broken it into 3 pieces. So 1, 2, 3.
That's weird.
Pi over 4s have broken it into 4. 1, 2, 3, 4. So it's how many like sections it breaks the top, like half of it into, is why. So that's why pi over 6 is going to be the 30 degrees. It's broken into 6 pieces. Okay, what was your question before I count the pi over
Can I text my
6s?
dad because I think he forgot one of my jerseys.
Yes, quickly.
Again?
Was it the white one?
I'm already not gonna be able to shoot today because my arms are dead.
What'd you do?
All right,
Last night.
so increments of 30 degrees. We start here at pi over 6.
You.
This is 1 pi over 6.
So,
At 60 degrees, I'm at 2 pi over 6, which reduces to the pi over 3 we have. Up here at 90 degrees, that's 3 pi over 6, which reduces to pi over 2. Over here, I'm at 4 pi over 6, which reduces to 2 pi over 3. Then I have 5 pi over 6 here at 150 degrees. Six pi over 6 here at pi. Next thing is 7 pi over 6.
I was not ready for this.
Then we keep going. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. And then 11 pi over 6 is 330 degrees. And then 12 pi over 6 or 2 pi is all the way around. So just like there are 17 degree values that are on here, there are also 17 radian values. Okay, so when I grade, you get a number out of 17 for each of those things.
Is this it?
Okay, the other two things that will be going on here, there are 16 of them. Okay, so what I'm going to do, and you can just do this part in pencil, is I'm going to extend these out because I want this to look like a coordinate plane.
Is this the dagger?
Damien Woolard?
Now, if you did your paper such that the word unit circles up here, it's probably not confusing to you where X and Y are, but I'm still going to label my X and Y axis here just so that it's not confusing for any reason.
That's a song.
Huh.
All right, so first thing I'm going to do is I'm going to label these axis points, okay, the XY coordinates of them. So the XY coordinate of this point right here is 1, 0. Okay, I'm just going to keep doing it in the color that I did that, but this is one of our colors.
Wait, what color is it?
I
Pick
messed
a
up
new color.
because you used red in the middle and I used black in the middle and then you used black on the outside and I used black on the outside. So now my black on the outside is the same as my black on the inside and it's gonna look weird.
So the numbers have to be a new color?
Huh?
That number has to be a new color?
I mean, it doesn't have to be, but I am using a different color. That's one of the 7.
That's one
Dang
of the colors.
it!
Okay.
Yes.
Oh, that's one of the 7.
Let's use brown.
Let's use brown. I'm gonna use purple.
All right, so this one is 1, 0. This one up here is 0, 1.
Nice.
This one over here is negative 1, 0.
This one's
And down here is 0, negative 1.
Nice. Light brown. Skin brown.
smell
Chestnuts brown. Smoking
All right,
chestnut
this
brown.
next thing that I'm going to draw on the unit circle, you don't need to draw this. I'm doing this as a visual for you. Okay, now I'm going to use the color that I'm going to use on the outside because we're going to be filling in numbers out here.
Will it help me to draw this?
Probably not. It'd probably be better for you just to watch.
Okay, cool.
Okay.
I'm gonna do it anyways.
Oh,
it.
okay.
Smell this.
Feels like chestnut
All right,
brown.
so what we're going to be putting out here now are the XY coordinates at each of these values, okay? So if we ask you for the cosine of a value, those are going to be the X values. The sine values are going to be your Y. You may want to note that somewhere. Cosine is X, sine is Y. I would say just maybe write it up here in the top corner. Cosine is X, sine is Y, so that you don't forget as you're learning this stuff, okay? Or if you
What
have a
is
separate
tangent?
piece of paper that you're doing your notes on, you can do that as well.
What is tangent?
We will talk about tangent in a minute.
That
Tangent's
sounds
the last thing that goes on here. All right, so as I'm doing this is the part you don't need to do, is I'm looking at approximately where this stuff hits to get the numbers, okay? Now, this is obviously not perfect, but it's close enough for us to get the visual. So I'm getting an XY coordinate, and this is going to be the coordinate for every single pi over 6. When I say that, it's the ones that have a 6 in the denominator that you visibly see, okay? Because obviously we just counted and I showed you that the pi over 3s and pi over 2s are also pi over 6s, okay? So our numbers that are our common numbers that we use, this is something you can, if you have a separate piece of paper, you can write down if you want, are root 3 over 2. I'm going to replace this in a second, so if you're writing this, write this now. 1/2 and root 2 over 2. Okay? Now, root 3 over 2, I'm going to make sure I give you the right decimal here. Root 3 over 2 is approximately 0.866.
Oh, that's the. Okay, I remember that.
1/2 is obviously Not even
0.5.
approximately. It is 0.5. Okay, and then root 2 over 2. Again, making sure. I do know these, but I'm just making sure I have them right. Okay. Is approximately 0.707.
707.
Okay. So root 3 over 2 is going to be when the number is really close to 1 visually. Okay, so what I notice here is I dropped this straight down. This is way out here. So that means my x coordinate is going to be root 3 over 2. Okay? I'm going to wait and make sure everybody writes this before I have it. Then, in here, coming across, and again, it's not perfect, but it's approximately halfway between, so it's going to be 1/2 on the y. So this coordinate point is going to be root 3 over 2 and 1/2. Okay? Root 3 over 2 and 1/2 always go together. One of them will be the x, the other one will be the y. Okay? Then for pi over 4s, it's nice and easy. Both of them are root 2 over 2. Okay, but I'll show you that in a second. Does everybody have what I have written up here so I can erase this?
I have it, but I don't.
I have no idea.
That's supposed to be in your backpack, Jack.
Oh, yeah, Josh.
What? This?
I'm so confused.
Like,
All right, so if that makes no sense to you, then just memorize it.
thank you.
All right, so this point right here is root 3 over 2, 1/2.
Is this a separate
Is
color?
this a
Is this for
separate-
writing?
We're going to have one color for all the pi over 6s.
So,
So yes, this is a new color.
Oh, sure, I forgot. Oh, I've already used light brown. Time for.
So the numbers will stay the same for all the pi over 6s. The only thing that's changing is the sign of them. Okay, the SIGN. Okay, so over here at 5 pi over 6, x is negative, but y is still positive. So this is going to be negative root 3 over 2 and positive 1/2.
That's the same color. Okay.
I'm writing this a little bit
Now,
box.
down here at 7 pi over 6, x is negative and y is negative, so both things are negative. So we've got negative root 3 over 2 and negative 1/2.
Go.
And then over here at 11 pi over 6, x is positive but y is negative, so this is root 3 over 2 and negative 1/2. All right, so that's one color.
Shoot, my bright brown looks like my light brown.
Bright brown? You mean orange?
Yeah, but this the light brown looks like the bright brown. These are not the same color.
So, are you saying redheads are like?
All right, the next thing I'm going to use, I'm using another color. I'm going to do the pi over 3. No, I'm doing pi over 4s. Pi over 4 is next. So this one's nice and easy. If I draw these lines over, again, you don't need to do this, but if I draw the lines over, they're a little bit more than halfway, but they're farther in than the root 3 over 2 value of 0.866. So this is the 0.707 or root 2 over 2. Both values are root 2 over 2. Pi over 4 should be your easiest one to memorize. Okay? So, again, at every increment of pi over 4, I've got root 2 over 2 and root 2 over 2. Again, the only thing that's different is the signs are changing. So at 3 pi over 4, it's negative root 2 over 2, then positive root 2 over 2. At 5 pi over 4, they're both negative. So I've got negative root 2 over 2 and negative root 2 over 2. At 7 pi over 4, I have positive root 2 over 2, then negative root 2 over 2.
Oh, I get it.
Shut up, Zach.
I get why one's negative and the other one's positive. And why
The
they're double
coordinate
negative.
plane.
Exactly.
the
You're
quadrants.
doing so good, Zach.
She didn't say that, so I actually used
It's self-explanatory.
I'm done with blue brown.
No, I'll.
All right, another color.
Where am I going? Wait, did I put that in the wrong spot?
Light blue brown.
No way.
All right, the increments of pi over 3s. These are easy. We just invert pi over 6. So it's 1/2, then root 3 over 2. Yes.
Can I get a new color? This light blue brown is too big.
Negative square root is-
So they are inverted.
Ew, yellow.
So at 2 pi over 3, it is negative 1/2 and root 3 over 2.
Oh, this one's too tiny.
Down here at 4 pi over 3, they're both negative. So negative 1/2, negative root 3 over 2. Over here at 5 pi over 3, positive 1/2, negative root 3 over 2.
Oh, I messed up. I messed up big time.
Leave it to Shepherd.
Uh-oh. I kind of moved everything up one.
How?
You might be better off to start over.
Well, it was just 2 of them.
Oh, okay.
Like, these ones supposed to go down 1. So I can just put an arrow saying go down 1.
So this is literally just the sign, because it's a 1. The radius is 1.
What are you talking
So,
about?
so it makes sense, right? Because it's the sine of 30 would have the. So, I think I get it. It's literally just what we've done before, right?
Pretty much,
No.
yes.
Like it's just the.
These
special
are all
sign.
special triangles.
Yeah, because the
yes.
root 2 over 2 is really 1 over root 2 because it's the 1 over the. Okay. I
Yes.
Get it.
So
It
it's
makes
like-
sense.
Daniel, get the piano.
No. It-
All right,
It's literally
really
1
quick, because we've got one more thing we need to get on here before the bell rings, are the tangent values. Okay? So, tangent, if you want to add this to your secret information that you have,
Secret.
tangent is y over x. Okay, so if we took and divided, which I won't do today for the sake of time, but if I can do them tomorrow or whatever, if I took the y value at each coordinate and I divided it by x, so 1/2, let me just do this one as an example, 1/2 divided by root 3 over 2.
There's a fraction in a fraction.
We keep change flip, 1/2 times 2 over root 3 would give us 1 over root 3, which I can't leave that way, so it becomes root 3 over 3. Okay? I'll do these tomorrow slower for you so that you'll have them. What?
What happened to the 4?
There's no 4.
Where are you finding a 4?
There's no 4. Alright, so this one is root 3 over 3. Every increment of pi over 6, the ones that have that on the bottom, are all root 3 over 3. I'm using another color.
You already used red.
It's not red, it's pink.
Yeah.
But I'm using a dark pink so you can actually see it. Alright, so all the pi over 6s are root 3 over 3. You may want to make a note that the value you're writing out there is tangent, just so that you don't forget. Now, I say that they're all root 3 over 3, but I got to pay attention to the signs. So if I divide a positive number by a positive number, I get a
Positive number.
positive. If I divide a negative by a negative, I get a
Positive.
positive. So in quadrants 1 and 3, your tangents will be positive. In quadrants 2 and 4, you have a positive divided by a negative or a negative divided by a positive. What do you get when you do that?
Negative.
Negative. So this one is actually negative root 3 over 3, and this one is negative root 3 over 3.
Mhm.
I think I only use 6 colors.
I'm colorblind.
I didn't get to use my pink.
All right, the pi over 4s. This one's the easiest one again. Root 2 over 2 divided by root 2 over 2. Keep, change, flip, everything cancels, and I'm left with 1. So positive 1 here.
Is
this the same color?
Is that pink
Yes,
still?
same color.
I should just use the same.
Over here, negative 1. I'm going fast. I can go back and do this. I just want to actually finish this in the video for today.
Oh, it's
Then down here, positive 1. Over here, negative 1. Now, pi over 3. The hardest one mathematically are the pi over 6s. Pi over 3 is root 3 over 2 divided by 1/2. I keep change flip. 2's cancel. I'm left with just root 3. So this is just root 3. Up here is negative root 3. Down here is positive root 3. And over here is negative root 3.
Good
Now,
job, Ryan.
there's 4 tangent values that are not on here yet. They're on the axis. Stay for 1 second.
1.
Good, I don't
0 divided by 1 is what?
0. You can't divide by
Zero.
0. So the
Undefined.
tangent values on the x-axis are 0.
Ooh.
On the y-axis, 1 divided by 0 is what?
You can't do that.
Undefined.
Undefined. So on the y, the tangent is undefined.
Under.
So the things on the outside of the circle, there are 16 xy values and there are 16 tangent values. So when you go and you're doing these, you should have 17 of each on the inside, 16 of each on the outside. I'll show you a little trick to help you memorize this tomorrow when we start, but I wanted to get through that today. And if there's any questions about what we did there at the end with tangent, I'll go back over that as well.
Okay.